Hello, and welcome to this lesson on constructing dot and cross diagrams to represent the electron transfer during the formation of ionic compounds. In today's lesson, we will start by learning how to create dot and cross diagrams. We will then use these diagrams to visually represent how electrons are transferred between atoms to form ionic compounds. So far, we've explored how ionic bonds form when atoms transfer electrons to achieve stable electron configurations. Building on this foundation, today's lesson will advance our chemical understanding by providing a visual method, dot and cross diagrams, to represent electron transfer. This will deepen your insights into the process of ionic bonding, allowing you to clearly see how elements interact at an atomic level to form compounds with unique properties. To construct dot and cross diagrams, we can follow a set of steps. Consider, for example, we want to represent the formation of sodium chloride. Start by identifying the two elements involved in forming the ionic compound. Generally, one will be a metal and the other a non-metal. These two different types of elements will react together to form an ionic bond. For sodium chloride, sodium is the metal. Chlorine is the non-metal. Next, identify the number of valence electrons for each element. This will help us understand how the electrons will be transferred. Sodium has one valence electron, as its electron configuration is 281. Chlorine has 7 valence electrons, as its electron configuration is 287. Then, draw shells around each element, representing the valence electrons. You can draw all the shells, or just the outside shell for ease. We'll use dots for sodium and crosses for chlorine. We have 1 dot for sodium and 7 crosses for chlorine. Now we'll show the transfer of electrons from the metal to the non-metal. Sodium will lose its 1 valence electron to achieve a stable electron configuration, like that of neon. Chlorine will gain 1 electron to also achieve a stable configuration, like that of argon. We can see this transfer of electrons here. After the transfer, draw the resulting ions. Sodium, having lost 1 electron, becomes a sodium ion with a positive charge because it now has more protons than electrons. Chlorine, having gained 1 electron, becomes a chloride ion with a negative charge because it now has more electrons than protons. Finally, encapsulate each ion in square brackets and denote the charges. By following these steps, you can concisely and clearly represent the electron transfer that occurs during the formation of any ionic compound using dot and cross diagrams. This method allows you to visualize how metals and nonmetals bond through the transfer of electrons, leading to the formation of stable ionic compounds. Let's dive into some GCSE level questions to apply our understanding of constructing dot and cross diagrams to represent electron transfer during the formation of ionic compounds. Question 1. Draw a dot and cross diagram to represent the formation of calcium oxide from calcium and oxygen atoms. First, identify the elements involved. Calcium is the metal. Oxygen is the non-metal. Next, determine the electron configuration. Calcium has 2 valence electrons, as it's in group 2 on the periodic table. Oxygen is in group 6, so has 6 valence electrons. Draw the valence electrons as dots for calcium and crosses for oxygen. Now we can represent the electron transfer. Calcium will lose its 2 valence electrons, and oxygen will gain 2 electrons. Next, show the formation of ions and add brackets and charges. Calcium becomes Ca2+. Oxygen becomes O2-. Question 2. Draw a dot and cross diagram to represent the formation of calcium chloride from calcium and chlorine atoms. First, identify the elements involved. Calcium is the metal. Chlorine is the non-metal. Next, we can determine the electron configuration. Calcium has 2 valence electrons, as it's in group 2. Chlorine is in group 7, so it has 7 valence electrons. Draw the valence electrons as dots for calcium and crosses for chlorine. As we can see, calcium needs to lose 2 electrons to have a stable electron configuration, while chlorine only needs to gain 1. Therefore, we need 2 chlorine atoms to take both of calcium's valence electrons. This leaves us with 1 calcium ion with a positive charge of 2 and 2 negative chloride ions. By working through these examples, you can see how to tackle GCSE level questions on constructing dot and cross diagrams for electron transfer in ionic compounds. Each step helps to clearly represent the process of forming stable ionic bonds between metals and nonmetals. In today's lesson, we focused on constructing dot and cross diagrams to represent the electron transfer during the formation of ionic compounds. We began by identifying the elements involved in forming an ionic compound, typically a metal and a nonmetal, using sodium chloride as an example. We determined the electron configurations of sodium and chlorine, noting that sodium has 1 valence electron and chlorine has 7. Next, we visually represented the transfer of electrons, showing how sodium loses its 1 valence electron to achieve a stable electron configuration, while chlorine gains this electron to also reach stability. We illustrated this transfer with an arrow showing the movement of the electron from sodium to chlorine. Following the electron transfer, we drew the resulting ions. Sodium becomes a positively charged ion, and chlorine becomes a negatively charged ion. Finally, we encapsulated each ion in square brackets and labeled them with their respective charges to complete the diagram. By following these steps, we created a clear visual representation of how electrons are transferred during the formation of ionic compounds. This method helps us understand how metals and nonmetals bond through electron transfer, leading to the creation of stable ionic compounds.